right, I'm sure you guys have heard of the word placebos before. Okay, and this is a way of having a control group. This is a type of control group. Okay, so like let's say we're testing to see if the new medicine works. So you have one group taking the new medicine and the old group, or you have one group taking the new medicine and the other group not taking the medicine. Well, if they're not taking the medicine, then that group knows they're not receiving any medication and they're not blinded, and they should be blinded. So we use the group something called a placebo. Often simply applying any treatment can induce an improvement. So what that means is the group taking the pill might feel better simply because they're taking a pill. Not because the medicine is actually working. It's the act of going to a doctor and talking out the ailment and taking something every day. All of that mentally could just make us feel better. And that stresses the importance of why we need to always have a control group, or in this case, when you're talking about like medicine, a placebo group. To separate out the effects of the treatment of interest, we can use a control treatment that mimics the treatment itself. This is like a fake treatment that looks just like the treatment being tested, and it's called a placebo. So it looks like the real treatment, but it's actually a fake one. Placebos are the best way to blind subjects from knowing whether they are receiving the treatment or not. Usually it's like a sugar pill or something like that. The placebo effect, so this is something a little different, and I actually have a video. CBS Sunday Morning did a great segment not that long ago on the placebo effect that I'm going to try to show y'all in class, or at least link it up for y'all to watch. But the placebo effect occurs when taking the sham treatment results in a change in the response variable. So even though the group's taking like sugar pills, that group shows an improvement because just the fact of taking a pill is making them feel better. That is why it is so important to have a placebo group, because the group taking the real medicine might show an improvement, not because of the medicine, but because of just taking something. So if both groups, placebo and real medicine, show improvement and about the same improvement, then that's kind of showing you that the medicine's not really doing anything. But if the placebo group shows a slight improvement, but the medicine group shows a statistically significant improvement, meaning more than what we would expect from chance alone, then we can kind of conclude that the medicine is working. Placebo controls are so effective that you should use them as an essential tool for blinding whenever possible. All right, the best experiments are usually, so these are all the things that you need to have a really great experiment. Randomized, comparative, meaning you are able to compare your results, double blind. So for comparative, like if I would have just given some people some medicine and nobody got a placebo, then I have nothing to compare to. Maybe those people just got better because they just got better, not because of the medicine. Double blinded whenever possible, should be. And last, controlled. And you can control either with a standard treatment or a placebo, and then also all of those outside factors you should control as well, like the amount of food, the sunlight, the water, all that other kind of stuff. All right, let's talk a little bit more about blocking. When groups of experimental units are similar in some way, it's often a good idea to gather them together into blocks. Blocking isolates the variability due to differences between the blocks so that we can see the differences due to the treatments more clearly. When randomization occurs only within the blocks, we call the design a randomized blocked design. A randomized block design. So we have something called randomized block, and then we have another something called completely randomized. The first diagram I drew in this note packet was completely randomized, where we went from our subjects, randomly split straight into our groups. This diagram here is block design. Notice that in this scenario, this is the same tomato plant scenario. The 24 tomato plants, we actually discovered 12 of them were from store A and 6 of them were from store B, which is not 24, it's only 18. So we're talking about 18 tomatoes here. 12 of them were from store A and 6 of them were from store B. And so what they're doing first is splitting them into the store A blocks and the store B plants. That way, if the store they came from had any effect on juiciness and tastiness, if the store they came from had any effect on juiciness and tastiness, it is being split out, and you can see that effect more clearly than if they were mixed in all together. Notice there is no random assignment here. We don't randomly decide which are from A and which are from B. I get this so often when we block by gender. You guys write like we're going to split into males and females, and y'all write over the line random. So that means you're randomly deciding who's going to be a male and who's going to be a female. That's not how blocking works. You already know which ones are males and females. You already know which ones come from A and B. So there's no random here. There is random here, okay, written over both lines. Because group A plants are going to get randomly split into the 3 treatments, and group B plants are going to get randomly split into those 3 treatments. Then we come to compare. We have our control group. That was either getting no fertilizer or the fertilizer we've been using, the half-dose group and the full-dose group. We compare. And we don't ever really need to compare back together again. It's just unnecessary. We're just seeing the effects of that fertilizer. Be careful when reading the previous diagram. We only have 3 treatment groups, not 6. Even though it looks like 6 total, we're just first splitting out into blocks. Our goal is to ensure that each treatment group will have 4 store A tomatoes and 2 store B tomatoes. This way we can isolate the effect of the fertilizer and eliminate any store A versus store B differences. All right, continuing on, in a retrospective or prospective study, subjects are sometimes paired. So this is another way of kind of sort of blocking. That's not the right word there, but paired, because they are similar in ways not under the study. Matching subjects in this way can reduce bias in much the same way as blocking. Blocking is the same idea for experiments as stratified was for sampling. Both methods group together subjects that are similar and randomize within those groups as a way to remove unwanted variation. We use blocks to reduce variability so we can see the effects of the treatment. We're not usually interested in studying the effects of the blocks themselves. For example, in 2007, pet food contamination put cats at risk as well as dogs. Our experiment should probably test the safety of the new food on both variables. Both variables in this case, I don't know why there's a question mark there, cats and dogs. Why shouldn't we randomly assign a mix of cats and dogs to the 2 treatment groups? What would you recommend instead? If the species, that's whether it's a dog or cat, has any effect on the healthiness of the animals, we will not be able to separate that effect out if we mix the groups. So for example, one group might get more sick than the other group, but that might be because that one has a few more cats in it, or those cats that it had in it were more susceptible to getting sick. We can't tell that, though. We might think it's the food making them sick because it's all mixed in. So instead, we should first block by species and then randomly assign the treatments within each block. And now we've controlled that source of variability. The AP rubrics require that blocking descriptions focus on the use of blocking to reduce variability within the treatment groups. You do not need to discuss comparing differences in the blocked groups themselves. So we don't need to compare like cats to dogs. It's just a source of controlling. It's a way of controlling another source of variability that could potentially affect the outcome.